In this video, we're going to turn our attention away from liquids, and now we're going to look at solids. And we start with sublimation and deposition. So, in a solid, molecules are constantly vibrating. They are not motionless. Molecules that are at the surface sometimes have enough energy that they'll break away from the surface and they'll form into a gas. That is called sublimation. While sometimes a gas, when it runs into the solid, will turn into a solid, and that's called deposition. And like liquid and gas, there's also dynamic equilibrium between the solid and the gas as well. So all solids, all molecular solids, also have a vapor pressure that's in a constant dynamic equilibrium. So solid going to gas is sublimation, and gas going to solid is deposition. So you want to remember those terms. Now, the heating curve of a solid looks exactly like the heating curve of a liquid. So this is water again, and as we add heat, we're going to raise the temperature of our ice until we hit 0. And then all the all the heat we put in goes into breaking our intermolecular forces. Goes into taking that solid ice and turning it into liquid ice. And remember, our equation for this process is Q equals mass times CS delta T. Heat equals mass times heat capacity times change in temperature. And until all of our solid turns into liquid, ice water will never go above 0. Ice will never go above 0 degrees centigrade. So if you have a glass of ice water and it's stable, the ice isn't melting, then that water is 0 degrees. All right. So let's think about melting and the energetics of it. So for a solid, the molecules that are going to leave are the high energy ones. And if high energy molecules leave, then energy will be lost from the solid. And if the solid doesn't get energy from somewhere, the temperature will decrease. Well, the solid will get energy from the environment, so it'll absorb that energy from the environment into itself, and therefore melting is endothermic. Energy is going into the process. While freezing is the opposite. If you freeze, you're taking your liquid and you're lowering kinetic energy. Therefore, energy is leaving your system and going into the surroundings. So melting needs an input of energy so when we melt something, we need to input energy to overcome our solid attractive forces, our intermolecular forces, right? That's why ice melts in the heat, right? And the amount of energy required to melt 1 mole of a solid is heat of fusion. It's the same idea as the heat of vaporization. We sometimes call it enthalpy. And this is an endothermic process, so delta H of fusion is always positive, somewhat temperature dependent. And the opposite, that is going from liquid to solid, is called crystallization. And just like vaporization, condensation were equal but opposite processes, crystallization and fusion are also equal and opposite processes. And when we talk about delta H of vaporization and delta H fusion, we can see that delta H vaporization is highly dependent on intermolecular forces. Delta H of fusion is not all that dependent on intermolecular forces. Everything has about the same delta H of fusion. And if we go straight from a solid to a gas, that's sublimation. All we need to do to get delta H of sublimation is to add delta H of fusion plus delta H of vaporization, and that'll give us our delta H of sublimation, because that is the energy it takes to go from a solid to a liquid, and then from a liquid to a gas, and sublimation is just going from solid to gas. And that's it for this video. See you in the next one.